Hello guys, welcome back. So in this video I'm going to be talking about the unit circle and what it's used for. So the unit circle is a circle that's used in parts of trigonometry but also precalculus, and it makes it more simple to look at different trigonometry angles when you're dealing with triangles and stuff. So the first thing that I should probably mention is that the unit circle is used in things such as light waves, sound waves, and electricity, because they all travel in waves that kind of look like this. So it follows a certain pattern, as well as using lengths and angles using sine, cosine, and tangent. So just as a quick recap, sine is opposite over hypotenuse, cosine is adjacent side over hypotenuse, and tangent is opposite over adjacent. And so what this means is that when you have a triangle, such as this, with the right angle, and let's say this here is your right angle, right? Your hypotenuse is this side, your adjacent side so when you're taking angles, if you have like an angle like this, and that's your theta, your angle, your opposite side would be the side that's opposite from this angle, so it would be right here, this side right there. That would be opposite, and your adjacent side would be the one that's right next to it, so this would be adjacent. And this works for every different angle, so I guess these two, that's not the right angle because you already know this angle right here. And what it's used for is to find the angle that what this angle is or what that angle is given your sides. Alright, so for the unit circle, what it is, it's a circle with radius 1. So this side right here, or any side on this circle, has a radius, and that radius is equal to 1. And that makes and that's what the whole unit circle consists of, alright? So let me teach you how to draw it out. Most typically it's divided into about 12 sections, a circle. So let's draw it like this, and then we'll divide it into 12 sections. And forgive my terrible drawing skills. Alright, so think of this as a coordinate plane. So if you imagine this right here, this right here is like your whole coordinate plane. This here is divided into 4 sections, such as this. And this is your positive side, your negative positive, your negative negative, and your positive negative, right? So keep that in mind for this part right here. This point right here is 1, 0. If you think about this point right here as the origin, that's 1, 0. This point right here is 0, 1. This point right here is negative 1, 0, and 0, negative 1. Alright, so when you think about a triangle, or first of all, these are divided into sections. So this part right here is 30 degrees. This is altogether 60 degrees. Or sorry, 45 degrees. and this is 60 degrees right here. So this side's 30, these two are 45 altogether, and these three are 60. And then this here forms a 90-degree angle. And the reason this works is, once again, if you have a triangle, and let's just say it's 30 because that's pretty typical, then, and if this side's 1, and you don't know these two sides, you can use SOHCAHTOA. So if you know sine of 30 is equal to opposite over hypotenuse, you know opposite, so let's put it as O for now, and then hypotenuse is 1. Maybe better if we put it as an X, so don't get confused. Then if you have 1 times this, if you do like cross multiplication, 1 times sine of 30 is, let me do that real quick. Is 1/2. So this side right here is 1/2. Alright? And that is your y value. Okay? And so then your x value, this value right here, so we'll put this as also x, I guess that too. Then, you know, we'll ignore the angle for now. So if you do sine of, I guess, theta. Actually, no. We'll do what we did before. If we do sine of 30 degrees is equal to, actually, my bad, cosine of 30 degrees is equal to x sub 2 divided by 1. Then cosine of 30 is rad 3 over 2. And so then this x value would be rad 3 over 2. Alright, we figured that out. So this point right here, its x is rad 3 over 2, comma 1/2. Alright. And that's how that works, right? So it builds a really good relationship once you're able to memorize it, and it's not hard to memorize once you get it. It follows a very similar pattern because these are divided into the same type of sections of the same type of like angle difference. So this is 30, 45, 60, right? So this half point right here is 45. Same for this half point right here is also 45 from this point right here. And this right here is also 45 from this angle right here. And this point right here is also 45 from these two. So these all right here in the blue are all 45-degree angles. So you imagine this here is rad 3 over 2 and 1/2. So right here it'll be the same, except it's negative rad 3 over 2 because the x is negative now, comma 1/2. And this one right here would be negative rad 3 over 2, comma negative 1/2 because both quadrants are now negative. And this here would be rad 3 over 2, negative 1/2, because the y part is negative. And so if you move on to the next one, you have a triangle that's kind of like this. So it has one, we know that's a 90-degree angle, and we know these are 45. So yeah, 45. So we know these two are probably going to be equal lengths because it's an not an equilibrium, like equilateral triangle, but since these two are both 42, it has the same type of equal relationship between these two sides. So sine 45 is equal to x over 1. And so x is equal to rad 2 over 2. And then comma rad of 2 over 2, because it's going to be the same for the other side. So this side right here is rad 2 over 2, comma rad 2 over 2. And this side here would be the same thing because it's also 45 degrees from its that main point right here. And it's the same thing, just in a different quadrant. So this right here will follow the same thing, except the x part is negative. So it would be negative rad 2 over 2, comma positive rad 2 over 2. And then this right here would be both negative. And then this part would be positive rad 2 over 2, comma negative rad 2 over 2. And then for the last one, it follows a very similar pattern. Since this point right here, see the long side right here? So if you like look at it in this type of perspective, like notice this right here is basically what this is right here. Like that. And this is 60 degrees. That's a right angle. That's 30, right? It's the same thing as this 31, but flipped to the side. So you can see this here is 30. And so it's the same as this one right here. Ah, it's a terrible triangle. And that's 30, 60, that's 90. If they're the same type of thing, this one's just flipped to the side. It's flipped vertically now. And so because of that, its x and y lengths are still the same thing. They're just flipped this time. So this here, instead of, this is rad 3 over 2, comma 1/2. This here is instead going to be 1/2, comma rad 3 over 2. Same numbers, just the x and y values are switched because this is now horizontally. So if we looked at this 60-degree angle, this opposite side is now going to be the longer side, which is this adjacent side. And then this adjacent side that's shorter right here in the 60 is going to be now the long side of its adjacent. So that's going to be the same for all of these. So right here it's going to be negative 1/2, comma rad 3 over 2. This side right here is going to be negative 1/2, comma negative rad 3 over 2. This side right here is going to be 1/2, comma negative rad 3 over 2. And that should be it for the unit circle. The way so all these here for the 45-degree angles, so it's halfway between each quadrant. If once again you think about it this way, like a general just grid, each half point, which is like the 45-degree angle, is gonna be the same type of length, which is they're all gonna be rad 2 over 2. It just depends on its quadrant. So like I mentioned earlier, I should do it here. So positive, positive, negative, positive, negative, negative, and positive, negative. So just depending on that will vary what these are. And then for these parts, the 1/2 rad of 3 over 2, I think of the 1/2 as the shorter one because 1/2 is like 0.5. Whereas rad 3 over 2, that's like, give me a second. Rad 3 over 2 is about 0.86. So that's the way I think about it. The rad 3 over 2 is always the longer side. So in the 60-degree angle, this long side right here, that y value is the rad 3 over 2. And then in here, the shorter one, the x value is the rad 3 over 2. Thinking about it that way. Alright, so that's going to do it for today's video. Let me know if you have any questions, and don't forget to like and subscribe. Thank you.